So we just finished solving rational equations. So this section deals with the application problems where you have the word problems. So you have to write the rational equation and then solve. So when the same number is added to both the numerator and denominator of 5/8, the result is 3/4. What is the number? So we're going to say x is our number. And it says if you add the same number to both the numerator and denominator of 5/8. So we have 5/8. And if we add our number to both the numerator and the denominator, the result is 3/4. So you want to solve your rational equation. And again, you can, since this one's set up as a proportion, you could cross multiply. Or you can do the least common denominator like we've been doing. Which would be 4 times 8 plus x. So multiply this whole thing by 4 times 8 plus x. So on this side, the 8 plus x's cancel, so you're left with 4 times 5 plus x. And on this side, the 4's cancel, so you're left with 3 times 8 plus x. Then you just have a linear equation to solve, so distribute. So we got 20 plus 4x is equal to 24 plus 3x. Subtract our 3x, so we get x on this side. Subtract our 20, 24 minus 20 is 4, so x equals 4. And this should work as long as x is not -8. You should have something that works, and you can check it. I checked it on the handwritten notes. You see that it does work if you plug in 4. It does give you the correct solution. So you can always check all of these. For the next one, this is a work problem if you're working together. So for this particular one pipe fills up whatever it is we're talking about. I didn't write the whole problem down. In 8 hours, another does it in 5 hours, and so you want to know how long will it take them together. Sometimes this can get confusing. So what I do is, if you've got two things working together, the portion completed or done by pipe 1 plus the portion that's done by pipe 2. So in this case, we've got two pipes, pipe 1 and pipe 2, has to give us one total job. If you had 3 pipes working together, then the portion by pipe 1 plus the portion by pipe 2 plus the portion by pipe 3 has to still equal one total job. So if you think of it that way, it makes it a little bit easier. And then what I always do is make a chart. So we have pipe 1, pipe 2. This just helps you come up with your equation that you have to solve. So you always do how long it takes it alone, how much can they complete in an hour. In this case, since we're talking about hours here, if it was minutes, part in 1 minute, if it was days, part in 1 day, or whatever the case is. So this is in hours. Together, it's going to take them so long, and then that tells you the part or portion by each. So when I fill in these numbers, it makes sense. So pipe 1 alone can fill up this, we'll say it's a pool, whatever it is, in 8 hours. So alone, it takes pipe 1 8 hours, and pipe 2 5 hours. So how much can pipe 1 get done in 1 hour? Well, if it takes 8 hours to do the whole thing, in 1 hour it'll have 1/8 of it done. And then in 2 hours it would have 2/8 done, 3 hours it would have 3/8 done, so on and so forth. For pipe 2, if it takes 5 hours for the whole thing, in 1 hour it would have 1/5 done. In 2 hours it would have 2/5 done, and so on and so forth. Together, that's what we want to know. How long does it take them together? So together they're going to work the same amount of time and have it all done. So whether that be that together they get it done in 3 hours or 4 hours or 6 hours or whatever. So this is our variable. So T for time and it's going to be the same because they're going to work together, so they're going to each start at the same time and finish at the same time. So the portion or part done by each is these two multiplied together, so this would be t over 8 and then t over 5. So to come up with your equation then, the portion done by pipe 1, well, that's t over 8. That's however long they work divided by 8, plus the portion done by pipe 2, well, that's t over 5, because it's however long they work, because pipe 2 is doing it in a fifth for an hour, or 2/5, or 1.5 over 5, or whatever the case is, so whatever t is. So this is multiplied together again, so t/5, t over 5, has to equal our one total job. So like I said, if you set up this chart and then you think of it this way, it generally makes the equation a little bit easier to come up with. So these are just numbers. You could just you know, add like normal and stuff, but we've been clearing fractions for rationals, so I'm going to multiply by the LCD. For 8 and 5, the LCD is 40. So if I do 40 times t over 8, I would get 8 goes into 45 times, so I'd get 5t, plus t over 5 times 40, 5 goes into 48 times, so 8t is equal to 1 times 40 is 40. So I have 13t is 40, which gives me t is 40 divided by 13. Well, we're talking about time. That doesn't really look that good, so you would say 3 1/13 hours, or you could do a decimal if you wanted. So together it will take 3 1/13 hours, or whatever that is as a decimal if you'd rather do a decimal. So because generally speaking is if they're working alone, it's going to take them longer, and if they work together it should take less time, so that makes sense. And like I said, if you set up this chart where you have your alone part and one, whatever your unit is here, hours, minutes, days, together will always be the same, t, and then you just multiply these two together, and it always has to add up to 1 because you're doing one job. If it asked you how long does it take them to complete 2 jobs, you would say equals 2, or whatever the case is, but generally it's only going to ask you about one job. So for the last one, I think here for this section, we have 1/3 of a number added to the reciprocal of a number yields 13/6. So what is the number? So x is going to be our number, and our reciprocal then would be 1 over x. So it says 1/3 of a number. Well, 1/3 x added to the reciprocal of the number, so added to 1 over x, has to give us 13/6. So here's our rational equation. We're going to clear our fractions. Our LCD is, we've got a 3, an x, and a 6, so 6x. So if we do 1/3 x times 6x, 3 goes into 6 2 times, so that's going to be a 2, and x times x is x squared, plus 1 over x times 6x, the x's cancel, we got 1 times 6 is 6, is equal to 13 over 6 times 6x, 6 is canceled, so we get 13x. So this is a quadratic to solve. You have to bring your x over to this side and set it equal to 0. And you can solve by factoring, completing the square, quadratic formula, whatever you want to do. So this one will factor into 2x minus 1 times x minus 6. So we have 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus 6 is 0. 2x minus 1 is 0, or x minus So you have two answers here, which is fine. And you can check both of those. Both of them work. If you do x is a half, I'll just show you on the screen instead of writing that down though. If you check x as a half, if you do 1/3 of a half plus 1 over 1/2 for the reciprocal, that gives you 1/6 plus 2, which is 13/6. And then for x is 6, 1/3 of 6 plus 1/6 is 2 plus a 6, which is still 13/6. So this one actually has two answers. Either one of these work, which I don't really care for this problem because it should, if one of them came out to be some weird number that didn't work, it would be better, but it's okay, because it says what is the number, so it implies there's only one, but there's actually two answers, 1/2 and 6. Either one works.